So in this video, let us solve a problem on Dijkstra's algorithm. So Dijkstra's algorithm is used to find the shortest path from the source vertex to other vertices. Okay. So in this question, we have a graph G. So it contains the vertices A, B, C, and the given graph is a weighted graph. We have assigned a non-negative quantity to each edge of this graph. Okay, so from A to B we have a weight 10, from B to C it is 20, and from A to C it is 40. Now let us find the shortest path from the source vertex A. So let me consider the vertex A as the source vertex. So the very first iteration is we need to assign the non-negative quantities to each vertices. Okay, so in the first iteration we will assign 0 to the source vertex and infinity to other vertices. So along with this we will write the weight matrix of this graph. So in the first iteration we have given the permanent weight to the source vertex A as 0, and we allocated infinity to other vertices, that is the temporary weight. So let us write the weight matrix, right? So we wrote the weights, the permanent and the temporary weights for the vertex A, B and C. So along 0, infinity and infinity we have to consider the minimum one. The minimum one is 0, right? So and that corresponds to the vertex A. So let me write A here. So now let us block the vertex A, right? So now look at the blocked vertex A. So look at the adjacent vertices of A. So we have the vertex B as well as the vertex C, right? So now let us allocate the new weights for these vertices. So here 0 plus 10 equals to 10, but we have allocated infinity in the previous iteration. So among 10 and infinity, let us consider the minimum one, so that is 10. And we have 0 plus 40 equal to 40. So we have infinity there. So among 40 and infinity, we should choose the minimum one as 40. So in the second iteration, so we have the new weights. So let us write them in the weight matrix. So in the first iteration we fixed 0 for the vertex A, right? In the second iteration we have allocated 10 to B, the vertex B, and we have allocated 40 to the vertex C. So among 10 and 40, which one is minimum? 10, and that corresponds to the vertex B. So let us write B here. So now we have to block the vertex B. So now look at the vertices which are adjacent to B. So we have the vertex A, so we already blocked that, just leave that, and we have the vertex C, right? So let us allocate a new weight to vertex C. So we have 10, 10 plus 20 is 30. So but we have 40 here, so let us allocate the minimum of these two numbers. The minimum of 30 and 40 is 30. So we have allocated 30. Now let us write the new weights here. Right, in the third iteration we have only one value, that is 30, so that corresponds to C. So let us write C here. So now from this weight matrix we can say that the shortest path weight required from A to A is 0. The shortest path weight required from A to C is 30, and the shortest path weight required from the vertex A to vertex B is 10. So now we can write the shortest path. Okay, so we know the shortest path weightage. Using that we can write the shortest path from each from the vertex A to other vertices. So we have a source vertex A. So from A to B and A to C we have to calculate the shortest path. So from the weight matrix we came to the conclusion that the shortest path weightage from A to B, the vertex A to vertex B, is 10. Okay, so let us write that here and observe the figure. So we have to choose the path which contains the weightage is 10 from A to B, right? So here, this is the vertex A and this is the vertex B. So this is the shortest path because the weightage is 10 here. And the shortest path weightage from the vertex A to vertex C. So from the weight matrix is 30. See, according to this weight, we have to choose the shortest path. So from A to C means we can go to from A to B and B to C. So here the weight is 10 plus 20 is 30, and we can also move from A to C directly, but the weightage is 40. So we have two paths here. So among these two, we have to choose the shortest path, the minimum weightage path. 10 plus 20 is 30, so that is the minimum weightage path. So from A to B and B to C, so that is the shortest path. Okay, thank you.